In this video, we're going to take a look at using the quadratic formula to solve a real-world application involving a rectangular auditorium. The first sentence tells us that the auditorium seats 1,395 people. I know this is rectangular, so I'm going to draw a rectangle and assign the area of that rectangle 1,395. That's the number of people that fit inside that rectangle. And I also know in an auditorium that I have rows and I have seats in each row. So I'm going to assign rows and seats as the sides of the rectangle. The second sentence tells me that the number of seats in each row exceeds the number of rows by 14. The word exceeds tells me that there's more seats because seats exceeds rows. So I have more seats and fewer rows in this rectangle. The final sentence asks me to find the number of seats in each row. So it would be really nice if I could let X represent the number of seats in each row, and if I could assign rows as something that is based on that X. Since I know I have more seats, and I have, by the number 14, the seats exceeds the rows by 14, I can subtract that 14, and that'll give me the number of rows. So rows is represented by X minus 14. The formula for area of a rectangle is base times height, and now we just have to fill in the information from the problem. The area of our rectangle is 1,395, the base is x, and the height is x minus 14. That allows me to write the equation 1,395 is equal to x times the quantity x minus 14. I need to distribute that x, and that will give me 1,395 equals x squared minus 14x. When I identify the equal sign, I see that it would be really nice and simple to go ahead and subtract 1,395 from both sides of that equation, and that gives me 0 equals x squared minus 14x minus 1,395. I'm going to jot down my quadratic formula, and I'm going to identify A, B, and C in this equation. A is 1, B is negative 14, and C is negative 1,395. When I take a look at the discriminant and I just calculate that, I plug in my negative 14 for B and square it, subtract 4 times 1 times negative 1,395, and that gives me positive 5,776. And this is a perfect square. The square root of 5,776 is 76, so I can just throw that into my formula. And that's one of the reasons I do this first. It really simplifies that formula. So the second part of the formula is negative b plus or minus that square root that I just found, 76, and that's all over 2a. So negative of negative 14 plus or minus 76 over 2 times 1. That gives me two possibilities, 14 plus 76 over 2 and 14 minus 76 over 2. The first one, when I add those together and simplify it, it gives me 45. And in the second one, when I subtract and simplify, it gives me a negative 31. So my x values from the quadratic formula are 45 or negative 31. And since this is a real world situation, we're going to throw out that negative value and work with the 45. Since I allowed x to be the number of seats, and that's what the question's asking me, I can just go ahead and say that there are 45 seats in each row, and that solves the question, or it answers the question.